All right, hello. So what we're going to be doing today is we're going to be going through the radian. And the radian is a unit of measurement for angles. So you should already know degrees. So like for instance, this can be a 30-degree angle. But you can also measure this angle in radians. But before we get into measuring with radians, we are going to figure out the origin of radians and how we derive the value of radians based off of degrees. So what we're going to start off with is we're going to start off with the unit circle. So if you're familiar with the unit circle, you know that the unit circle is a circle with 180 degrees. So what we're going to start off with is we're going to start off with the radius of the circle. And the radius of the circle is the value of 1 radian. So the radius of the circle is equal to 1 radian. So let's have this in blue. Anything to do with the radians will be in blue. Yeah, that's a nice color. So what we can do is we can start going around, is we can take this length, this blue length right here, and we can start going around the circle. So if we start here, going around the edge of the circle, we have a distance of 1 radian, 2 radians, 3 radians, and then if we add a last little bit right here to the end, so we've gone halfway around the circle, we get pi radians. So, and the cool thing about reaching pi is that in the unit circle, measured in degrees, if you go halfway around the circle, you get 180 degrees. So these two measurements are equivalent. So pi radians is equal to 180 degrees. So this is actually a very important ratio that is used to convert from degrees to radians. So from pi to, so it's the, for every pi radians, you get 180 degrees. So let's practice doing this conversion. So let's start from converting from degrees to radians. So for my example, we're going to have 270 degrees, and we're going to convert it to radians. So the first thing we're going to want to do is we're going to add the ratio. So we're going to multiply it by the ratio. And whatever you put on top is the unit that we're going to get out. And the unit we want to get out is radians. So we put pi on top, and we put 180 degrees on the bottom. Now, when we multiply this together, the degrees will cancel out, and we will end up getting 270, oh, that's too much, 270 times pi divided by 180. And if we simplify these red numbers, we will actually get, in full radians, 3 pi over 2. So 270 degrees is equal to 3 pi over 2 radians exactly. And if we turn this into an irrational number, just as it is, we know that this is about 4.71. So this is approximately 4.71 radians. And we can go the other way. So we can start off with, for example, 3 radians. And we want to convert 3 radians to degrees. So we're going to expect this to be slightly less, a good bit less than 270. So let's start by multiplying it by our ratio. So this time we want to get degrees out of this ratio. So we're going to put the degrees on top. And we know that it is 180 degrees per pi radians. So when we multiply these two numbers, the radians will cancel out. But because we don't actually write down the unit for radians, we just leave it as is. So what we get is we actually get 540 over top of divided by pi, which is now in radians, well, which is now in degrees. So the interesting thing about degrees is that degrees really isn't a unit. It is kind of a representation of scale. So when we had a circle, we decided that we would divide it into 360 degrees. So it's not really a unit. It's a little different. But now that we have this number in degrees, we can divide it out, and we get 171.89 degrees. So now we know how to convert from radians to degrees, and we know what radians are. And there's one more piece of information, which is a second way to derive radians. So as you can probably guess, this involves the unit circle. So we're going to draw ourselves a circle, just like that. And we're going to start from the center, and this time we're going to draw a nice angle right from the center. And this angle is going to be angle theta. And the terminal arm is going to be equal to the radius of the circle, and so is the initial arm. So we have the initial arm, which is length radius, and the terminal arm, length radius. And then we have one last part over here. This area between the initial arm and the terminal arm is called the arc. And we're going to be using the length of the arc when we are deriving the value, the ratio between degrees and radians. So one relationship that we have come to understand between angles, the radius, and the arc of a circle, when you draw it like this, is that the angle is equal to the length of the arc divided by the radius of the circle. So if we want to find the conversion between radians and degrees, we're going to set our angle to 360 degrees. That is going all the way around the circle. So that means that the length of the arc is equal to their circumference, and we know that their circumference is equal to 2 pi r, which is the same as pi times the diameter, because the diameter is just the radius twice. And of course, that is still divided by the radius. So we can cancel radius out over here. And we get 360 degrees is equal to 2 pi. And now you can probably guess what we're going to do. We're going to divide both sides by 2. And we get 180 degrees is equal to pi. And that is our wonderful conversion between radians and degrees.